CSET, Subtest 1. This is from 1.2b and C. It's quadratic work. It's an anti-question. So what we're looking at here is a question with complex roots. There's one other piece of information that's been given about this quadratic, and that's that it's of this form. You'll notice that the a is missing. So what we know is that the lead coefficient is just going to be 1. So first, what we have to recognize is that we're going to be using conjugate pairs theorem, which means if a plus bi is a root of a polynomial p of x, then a minus bi is a root of p of x. So that is conjugate pair theorem. Heretofore referred to by me as a CPT. Now, we've stated the theorem and we wish to apply it. Since 1 plus I is a root of q of x, one minus I is also a root. So what we know is that knowing the root means that we can go into this form, x minus the first root and x minus the second root. However, what ensues is something that looks very, very messy. And if you wish to multiply that out to solve for what this quadratic is going to look like, be my guest. I'm going to erase this because I'm going to recognize that this is a dark alley. I don't want to have to multiply this whole entire thing out. This is a messy form of foiling. So I'm going to write ick. Get rid of this idea. We have two forms left of the quadratic. We're going to go ahead and put it in standard form. For all quadratics of this form, for any quadratic of this form, you're going to have the idea that R1 plus R2 is the opposite of B over A, and R1 times R2 equals C over A. These are two flashcard ideas. Now, applying this, we have one plus I and 1 minus I equaling the opposite of B over A. We know that A is 1. So, I's cancel, we get 2 is negative B, so negative 2 is B. Over here, we multiply it out. That's C over A, and we know that A is 1. So we get 1 minus I squared, and I squared is 1, so it's 1 minus negative 1. And we get 2 is C. So we have B and C solved for, and we already knew from the beginning that A is 1. I only wrote that at the top of on the question, so I should probably put that somewhere in my kind of explanation here. We started off with CPT. Now once I have my roots, once I dive into this form, it'd be a good place right here to note that since A equals 1, or we could say that A equals 1, and that's just a given. That would be the explanation for plugging in these two 1 values. Now we have A, B, and C solved for, so our equation is x squared minus 2x plus 2 . Part A is almost done. The only thing left is to solve for the vertex of a quadratic. There are two ways to do it here. We can take the average of the roots. Most people don't think that way. That's the way I do, but I think that for most people what they do is they go straight to the x vertex flashcard idea, which hopefully you're already reciting with me, but if not, the x vertex is the opposite of b over 2a always, and we can just plug in our a and b values and get opposite of negative 2 over 2 times 1, giving us an x vertex value of 1. Take that and plug it back into the equation. We get a y value of 1 squared minus 2 times 1 plus 2, so y is 1 as well. So the vertex is 1, 1. Taking a look back at what we have so far, this was our first idea, transitioned over to our second major idea, involving our flashcards. Conjugate pairs theorem. It's kind of a flashcard idea as well, it should be memorized. You know, just roll out of your bed one morning, are able to recite suddenly conjugate pair theorem. You need to say it, at breakfast each morning for a week or two. Now, the second part was over here, and the third idea was over here. So I'm going to go ahead and label it 1, 2, and over here we're solving for our vertex 3. Those were the 3 steps involved